It's very important to know the domain and range of different functions using their equations as well. And this tends to be a little trickier for students. So I've got some guidelines for you, and then we'll practice with some different types of functions. So first of all, domain. The domain is the set of all allowable values of x in the function. So how do we know which values are allowed? Here's my suggestion. Start with assuming everything is allowed unless certain characteristics of the function rule are evident. For example, we can't have a value of x that makes the denominator equal to 0. So if you have a fraction with an x variable in the denominator, look and see if it is possible to make the denominator equal to 0 with a certain value of x, and that will be a value of x that will be excluded from the domain. You also can't take the square root or any other even root like a 4th root or a 6th root of a negative number. So are there any x values that would cause you to take the even root of a negative number? If so, those x values are not allowed. Any value of x which causes the output to be undefined, and we will talk about other types of functions later where certain output values are undefined with certain input values. But for right now, we're going to focus on the first two. We can't make the denominator equal to 0, don't take the square root or other even root of a negative number. So let's go through, first of all, and look at the domains of these four functions. All right, so when we're thinking about the domain, it's often helpful to think, could I put positive values of x in this function? What would happen? What would happen if I put negative values? What would happen if I put 0? Are there any fractional values? So kind of think through the different categories of numbers. So this is absolute value. So let's see. If I were to put, say, a positive value in for x, I could put in 5, for example, and I would get 0. The square root, or the absolute value of 0 is 0. That's perfectly good. If I put in other numbers bigger, like 10 or something, I could get 10 minus 5 is 5, and the absolute value of 5 is still 5. What if I put in like negative 2? Well, I'd have negative 2 minus 5, which is negative 7. The square root, or the absolute value of negative 7 would be positive 7, but that's still something that's allowed. So I can't see any problem with any values of x. I could put any value of x in this function. So the domain is all real numbers. We're going to use our interval notation. So the domain is all real numbers. I could put anything in for x. Let's look at number 2. Okay, now here's a fraction. Whenever you have a fraction involving variables in the denominator, you have to look. Are there any values of x that would make the denominator equal to 0? That's my first restriction here, because that is an undefined number. And I could see that if x were negative 5, that would give me 1 divided by 0, which is undefined. So x cannot equal negative 5, because that makes the denominator equal to 0. So not allowed. Could I have x be any other number? Sure. No matter what else I put in there, it's allowable. If I put in 4, I would have 1/9. If I have negative 2, I would have 1/3. Even if I had a number like negative 4.999, I would still have 1 divided by a very small number, which would give me a very large number, but it would still be a valid number. So this is the only number I am not allowed to use. So that means I can use anything less than negative 5, and I can use anything greater than negative 5. So in other words, I could use x less than negative 5, and I could do x greater than negative 5, but just not x equal to negative 5. So the way I write that, so if we were to look at a number line, okay, so here's negative 5 on my number line. Not allowed to use that. But I could use anything less than that, and I could use anything greater than that. So think of this as negative infinity, and this is positive infinity. So I'm going to write two inequalities, one from negative infinity to negative 5, and then one from negative 5 to positive infinity. So my domain here is negative infinity to negative 5, not including negative 5, so no square bracket, or negative 5 to infinity. Now, when we see or, there's a little symbol we use in math for or. It's a right side up, looks like a capital U. So I could also write this as negative infinity, -5, union. It's also known as a union. In other words, I'm putting these two together, or -5 to positive infinity. So that's how we would write the domain for this function. In a simpler one, we could say all real numbers except for -5. But that's basically what we're saying is all real numbers except for -5. We go from negative infinity, we go to -5, then we have this little gap, and then from -5 to positive infinity. Okay, the next one. Now we have a square root. So we look at our second exception. We can't take the square root of a negative number. Now, that doesn't mean that x can't be a negative number. It just means what's under the square root can't be a negative number. So for example, if x is equal to -1, then I would have f of -1 is the square root of -1 plus 5, which is the square root of 4, which is 2. Perfectly legitimate. So x can be negative. We just can't let the quantity x plus 5 be negative. So we need to have x plus 5 has to be greater than or equal to 0. Now it could be 0 because I can take the square root of 0. The square root of 0 is 0. That's allowed. So if x has to be greater than, x plus 5 has to be greater than 0, that means x has to be greater than or equal to -5. So if I put -5 in for x, I would get the square root of 0. That's allowed. If x is anything bigger than -5, like -4.5 or -4 or -3, whatever, the quantity x plus 5 will be positive. And so I'm good to go. So my domain here is greater than or equal to, x is greater than or equal to -5. So square bracket on the -5 because that's included all the way to infinity. So just once again, remember, it's the quantity under the square root bar that has to be positive. So any x value that makes, or I should say it has to be non-negative. It can be 0. So the quantity under the absolute value bar has to be 0 or positive. The smallest value then that x could be would be -5 to make it 0, or it could be anything bigger. Okay, now, number 4 is very similar to number 5, except the quantity, the square root of x plus 5, is in the denominator, which means I can't have that quantity equal 0. So I have the same domain as I did in number 3, except I can't include -5. I can't say the square root of -5 plus 5, because that would be the square root of 0, and I can't make the denominator equal to 0. So if x equals -5, then the square root of x plus 5 equals 0, and then the denominator equals 0, and that's bad. We don't want that, okay? So we just have to stay with greater than or equal to 5, or greater than or equal to, we have to just stay with greater than -5. So -5 to infinity is our domain. So we just leave off the -5, make that a curved bracket instead of a square bracket. So x has to be greater than -5, not equal to. Okay, last one. X plus 5. Okay, so do we have anything in a denominator? No. So I don't have to worry about making the denominator equal 0. Do I have a radical sign? No. Is there anything else that gives me a concern about adding 5? Can I add 5 to any number and get a valid real number? Yes. So there's no red flags here, so this is just all real numbers. So this is a case where, hey, go start with all real numbers and just see if there's any problems with that. No problems, all real numbers. Okay, now we always start by finding the domain, because the range, remember the range is a set of y values, and the y value is the dependent variable. It's dependent on whatever x is. So once I know the domain, then I use the domain to help me find the range. So the range is a set of all possible values of y in the function given the domain. So we start by finding the domain, then see what y values are possible for those x values. So as we're considering possibilities, you remember to include both positive and negative x values as well as 0. whatever's possible in the domain, but remember to include those when you're checking for your y values. Also make sure to check values of x that are between 0 and 1 or 0 and -1. In other words, fractional values, because sometimes that will give us values of y that we wouldn't get when we used whole number values for x. And then think, does the function rule itself restrict the y values to only certain types of numbers? And I actually don't have an example of that here, but for example, if I have f of x equals x squared, okay, when I square a number, it's always positive. So if I square a real number, I should say it's always positive. So that means I'm only going to get positive values for y and 0. Okay, so I can't get any negative values for y no matter what x is on this. Okay, so this would be y is greater than or equal to 0 for this one. Okay, so let's go back in here and look. Okay, so I can have any values of x. But what about y values? Okay, this is an absolute value sign. Absolute value means take whatever number that is in the, what's called the argument of this function, or what's the argument of the absolute value, what's inside the absolute value, and make it positive. So if there's a negative number inside the absolute value, it becomes positive. If there's a 0 in the absolute value, it stays 0. So what's the smallest value I can get for y? Well, it's going to be 0. I can't get any negative numbers. I can only get non-negative numbers. So y has to be greater than or equal to 0, which means my range is 0 to infinity. Because this is absolute value, that's how we know. So this is a case where the rule, the function rule, does restrict what y can be. Okay, so let's take a look at this. Now, I have two sections to my domain. I have values less than -5 and values greater than -5. So let's pick a value less than -5. So let's say -4. Sorry, that would be bigger than -5. Let's say -6. So if x is -6, I would have 1 over -6 plus 5, which is 1 over -1. That's a negative number. So if x is less than -5, that means this x value is going to be a bigger number, a negative number, but bigger in size than 5. And so overall, it was going to make the denominator negative. If x is greater than -5, then like -4, -3, -2, then this denominator is going to be positive. So I can get negative values for y, and I can get positive values for y. Can I get 0 for y? No, there's absolutely no way to make y equal 0. It's going to be 1 over a negative number or 1 over a positive number, but never 0. Also, if we have a number that's really, really close to -5, but not equal to -5, you're going to end up with a really large value for x. For y. Let me show you. So I'm just showing you some values here. If I put in a number that is greater than -5, notice -4 is greater than -5, I would get a positive number here, 1. If I put in a number less than -5, -6, notice that I end up with a negative number, in this case, also -1. What if I put in a much larger value less than -5, -100? I get -1 over 95. If this was a positive 100, I would get 1 over 105. So I could get, you can see I can get positive and negative numbers for y. But how big can y get? Okay, so right now we see as x gets bigger and bigger, y is going to get smaller and smaller, because as the denominator gets bigger, the overall size of the fraction would get smaller. But what if I pick a value that's really close to 5 but not equal to 5? So 1 over -4.999 plus 5, notice that gives me 1,000. So if I pick a number really close to 5 but not equal to 5, I can make y really big. As a matter of fact, I can make y even bigger. Let me do 1 divided by -4.99999 plus 5. Okay, so I can make y even bigger. So the closer I get to 5, the smaller I make the denominator, the larger the numerator, the larger the fraction becomes. So you can see that I can get all kinds of values for y, I just can't get 0. So we find out that our range then is that y can equal anything except 0. So we say negative infinity to 0 union 0 to positive infinity. So there's the range. Okay, number 3. We have the domain negative 5 to infinity. So I don't even have to consider any other values of x except for these values. None of the other values are allowed. So let's just start out when x is negative 5. So if x equals negative 5, y equals 0. If x is greater than negative 5, then that just makes y a positive number. Okay, it's a positive number, a number bigger than 0. So we can just say for the range then that y is greater than or equal to 0, because these values of this value of x gives me 0 for y. Anything bigger gives me a number that's bigger for y. So 0 to infinity. Okay, same thing here with number 4. Okay, the square root of x plus 5 is going to be a number that is bigger than 0. It can't equal 0 because I can't divide by 0, but anything bigger than negative 5 is going to make the denominator bigger than 0. Therefore, y could just be any positive number. If x is really, really close to negative 5, but a little bigger than negative 5, but close, then I'm going to have a really small denominator, like negative 5.01 plus 5. Divide 1 by a really small number, and I get a really big number. Just kind of like what we did up here. Well, exactly like what we did up here. So y could be any size number. It just can only be positive. So for the range, is 0 to infinity. So we see it's the same thing. It's just that negative 5 here is included, and so 0 is included for y. Here negative 5 is not included, so 0 is not included for y. And if I take any number and add 5 to it, I can get any number. I can get, if I take like negative 100 and add 5 to it, I get negative 95. If I take 100 and add 5 to it, I get 105. If I take negative 5 and add 5 to it, I get 0. I can get all possible numbers for y because adding 5 to any real number gives me any other real number. So the range here is all real numbers. No restrictions on what I can get for y when I just add 5. So this is probably one of the trickier topics is this domain and range, and we'll be doing a lot of practice with this for various types of functions all year. So this hopefully is helpful to at least get you started, and we'll definitely do more practice with this.